Okay guys, you're going to have to really bear with me here. I'm going to try to explain this as clearly as possible. That's obviously though why I do a lecture with you guys and then allow you to ask questions in case there's anything that was confusing in this or in the assignment. So here we are, 10.1 honors, 8.1 math 7, okay? So it says solve problems involving scale drawings. Okay, how can you use scale drawings and proportional relationships to calculate actual measurements? Okay, so the easiest thing I can think of, so first vocab, scale drawing, drawings of an object that are proportional or is proportional, okay? One of the examples that we always have is a blueprint. Every time you build a house, you have a blueprint of what it's going to look like, okay? And so it's to scale drawing. They'll say like 1 inch equals 2 feet. Okay, and they're looking for that proportional relationship, okay? So in other words, for the unit rate, right? If it's a unit rate, that what you're saying is 2 feet for every inch, okay? So that's what we're gonna look at in these examples. One other thing they're gonna cover in here that they didn't really talk about in the examples, but when I looked through the Excel, I saw this. You're gonna have to know that every single triangle has 180 degrees. That's every single one. It doesn't matter if it's scalene, equilateral, whatever, okay, a right triangle, it's gonna have 180 degrees. You can see right here, I've got a 90 degree, in other words, a right triangle. There's 90 degrees here, 45 here, 45 here. You add those up, that's 180 degrees. If I have an equilateral triangle, you have 60 degrees on each side, that's 180 degrees. It doesn't matter what type of triangle it is, all the angles are going to add up to 180 degrees. And we'll get into that in more depth as we go through this unit, Unit 10 or Unit 8, depending on which math class you're in. All right, so this is where you're going to have to really be patient with me here because I'm going to try to explain this as clearly as possible. Okay, so for this one, it's example 3. Okay, now in example 3, they were talking about a barn. Okay, and so they had blueprints for the barn. And what they were, and they show them up here, is in the blueprint it shows that it's 10 inches by 20 inches. And then this shows that this side, the 10 inches, would be 150 meters, okay? But what they want to do is they want to downscale that barn 2/3 of the size, okay? And then they want to go through and find out what is the amount. In other words, how much bigger is that than the original blueprint, okay? So here's how this works. The first thing I have to do is I have to figure out the unit rate, the proportionality, okay? The way I did that is I put meters over inches. So remember, these are all division problems, right? So I look at the one that I have both of them for, this and this. In other words, it's 150 over 10. Now if I reduce this down, it's 15 over 1. So what we're saying is, for every inch in this diagram or this blueprint, it's worth 15 meters. Okay, so we found our unit rate, 15 meters per inch. Okay, so what we're going to do here is, we're going to go through and figure out then the width based on that. So we have the length. So our length right now for the original barn is 150 meters. They already told us that. So the width would then be this 20 multiplied by the 15, because we found out that there's 15 meters for every inch, and that's going to give us, we shouldn't even look at it, 300 meters. So what they're saying is the barn at this point is 150 meters by 300 meters. But now what we need to do is we need to go through and we need to bring it down. So virtually what they're saying is, we made this barn, it's too big, right? We want it 2/3 of the size, but we want it to look exactly the same. So what would be our new ratio, our new proportionality? Instead of 15 meters per inch, what is it going to be, and how do we figure that out to downscale it? So we can build the exact same barn, but just smaller. Okay, so in other words, what I do is I take for the length, okay, I go through and I multiply the 150 over 1 multiplied by 2/3. So in other words, remember we got to cross cancel here, right? They call it cross multiplying, some of the teachers. I call it cross canceling because we're actually canceling the numbers out and reducing before we multiply. So in other words, 3 and 150 can both be divided by 3. 3 divided by 3 is 1. 150 divided by 3 is 50. We find out that the length should be 100 meters. See how the length changed from 150 meters to 100 meters. The width, we do the same thing. We take the 300 that we figured out, we put it over 1 and multiply it by the 2/3. Again, we can cross cancel and we find out that the width of the new barn would be 200 meters. So now we know this right here is going to be our length and width, okay? And we need to figure out now what is the proportionality to the blueprint, the original blueprint. What would I change these to, okay? And so what we do is we go through and we take the 10 over 20, okay? So in other words, we're going to go through, and this is a 10 by 20, right? So we take the 10 over 20, all right? And we see what is it equal to if we do the 100 over 200. So our scale factor ends up being that we would multiply by 10. So what this does is we have a scale factor of 10 and we know that it is still proportional. So that's what they were trying to explain in that last example. It's a scale factor of 10 now instead of 15. This was our unit rate, our unit of proportion, our constant of proportionality was 15 to 1. Now it becomes 10 to 1. So in other words, for every inch, there is 10 meters. Okay, guys? And then they could use the same blueprints to build the same barn, just smaller. A little bit hard to understand, so like I said, if you have a hard time, ask me questions. Okay, let's go to the next one. This XL was really, gave me a little bit of problems, and I wanted to make sure that you guys understood it really well, okay? So hopefully there's no issues here. Okay, so this is what they're looking at, okay? They have a, let me read the scenario. It says a map of a highway has a scale of 2 inches equals 33 miles, okay? The length of the highway on the map is 6 inches. So I wrote down the different things that we already know so that instead of looking at the story problem, we could break it down into different aspects. It says there are 11 rest stops equally spaced on the highway, including one at each end. You are making a new map with a scale of, what's the new map? 1 inch equals 30 miles, okay? How far apart would the rest stops be on the new map? Pretty difficult, right? They're getting harder, okay, guys? This is the last unit for Math 7, so they're going to challenge you up to that 8th grade level, and definitely Honors is getting challenged too the same way to make sure that you're getting those 8th grade standards down. So what I did was I wrote down the different aspects. We've got 2 inches equals 33 miles. The highway is 6 inches long on the map. There are 11 rest stops equally spaced. So what I did was I did this, and I did this because I wanted to make sure that I was going to divide it by the same amount. In other words, when I do this, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in other words, you would think you divide it by 11, you'll see when I say that, but instead we should be dividing it by 10 because they said they have a rest stop at each end. Okay, so the first thing I need to do in this scenario is to find the unit rate. In other words, how many miles per inch? Okay, so when I do that, what it turns out is I'm going to do, or no, actually what I did was I did this a little bit differently. I went through and I said, okay, how many miles is the actual highway then? So what I did was I took and I said, okay, I've got 33 miles, right? So I'm doing miles over inches. So I've got 33 miles for 2 inches, but I need to know how many miles would that be in 6 inches. This is proportional, okay? This is you doing the law of ratios. In other words, I'd multiply this by 3, I'd multiply this by 3, we get 99 over 6. In other words, it's 99 inches, right? Or sorry, 99 miles for those 6 inches. That highway is 99 miles long, okay? So once I found out that, and that I was going to divide by 10, then what I did was I went through and I took the 30 miles and 1 inch. That's my new ratio. That's the one that they're talking about here for the new map, okay? And they want to know how far apart are the rest stops on the new map. So it's 30 miles, right? So what I did was I put that equal to the ratio we just found, the 99 over 6, okay? Oh, sorry, just 99. We don't need the 6 inches anymore because we are going 30 miles per 1 inch. So I figured out by dividing 99 by 30 that I'm going to multiply this by 3.3. I'm going to multiply this by 3.3. That means that each one of these, okay, so remember this is miles over inches. This tells us on the new map that the highway, that's 99 miles, should be 3.3 inches long. Okay? Then what we do, told you this one was complicated, huh? Is we divide the 3.3, we divide it by 10. Because they want to know how far apart are the rest stops on the new map. So when I divide that by 10, I get 0 and 33 hundredths. In other words, if I'm doing the map, I have to measure that small and go through and make sure that each of those rest stops are 0 and 33 hundredths of an inch apart. Okay, so in other words, a third of an inch, right? They have to be a third of an inch apart. And that's what they're looking for in that answer. They want the decimal. Okay, guys? So don't forget that. Now, I can go over this again when we go through and do the other lessons. Don't think just because I do it in the lecture that we can't do it in the classroom also. It's just one of those things where if you can get it off the lecture, awesome. If you can't, then we can go over it and at least you have some kind of foundation or understanding of what we're looking at. Okay, guys? Now, don't forget to watch the examples. That's very important to go along with the lecture. And make sure you keep it up. Okay, guys? Hopefully this wasn't too bad. All right, we'll talk to you soon.